How to integrate successfully. Andrey Putin. Hello everyone. Integration is a very important and a deceptively simple topic. It is deceptively simple because after being 26 years in IT, I still notice that today, in a lot of teams, integrations are not done correctly. Integrations between systems is a very boring task. It's a boring task not only technically. There is nothing to code really, but it is also a problem that does not apply to your domain. For example, you're developing, let's say, a CRM system. Well, you don't really need to have knowledge about e-commerce. In addition, there are many different approaches and disbeliefs. I've already heard an ESB being called a message broker and vice versa. Some companies reject ESBs because they claim having a microservice. These people usually don't understand what microservice architecture is. Let's look at what is a perfect integration and what is a perfect architecture. What is a successful integration? It is an integration in which errors are encapsulated. If one stream goes down, everything else keeps on functioning. Everything is encapsulated in there, including the workload. Because in theory, can you have a cloud service with 100 RPS bandwidth? Well, yes. What will you do? Your integration circuit should take this into account. I have also noticed another very important pattern in most companies, especially in Russia. I see the trend where engineers are doing help desk and technical support tasks. Your online order is lost. Who takes care of that? A sleepy engineer opens his laptop in the middle of the night to solve the problem. That's not what a perfect architecture and a perfect integration is about. A simple example. Don't be surprised by the design. It's not very technical. It's just the way the designer saw it. We have a simple example here. A CRM system and an e-shop, and only 2 streams. Today, this won't even be considered to be a system. Can we do a point-to-point integration here? Do we need an intermediate layer to do this integration? Let's look at context issues here, and also let's look at service architecture issues. Your entire circuit, IT circuit, it can be either a microservice or a monolith. First, let's talk about context issues. From the point of view of a CRM system, a client can be one set of attributes, but from the point of view of an e-shop, the same client can be a completely different set of attributes. And in a perfect architecture, they have to be independent of each other. The e-shop manager should say, I don't need the names anymore, because in fact, he has his own KPI. What is his KPI? What is the output of the shop? Obviously, orders. The first problem here is the different contexts. What will point-to-point integration lead to? Well, one of the systems will know the context of the other. For example, if we write the piece of code in the CRM system, it will know about the changes done in the eShop. It will know that we don't need the name anymore and that this field needs to be changed somehow. So why does the CRM system need this? From the perspective of its VFP, the CRM system doesn't need it at all. In addition, if you need to upgrade the CRM system or the eShop, you will need to change the whole CRM system. Do you understand the problem? This shouldn't be happening in a perfect architecture, because even if we add a second eShop, nothing should change in this architecture. And what happens in reality? And this happens even when teams try to solve integration problems. For example, you have some kind of an issue. Let's take the same lost order or a wrong price. Only an engineer is able to figure out the chain of events which should be followed to figure out where the price is and what it is affected by and where the actual issue is. And this must be a very smart engineer who will be able to build and hold the whole sequence in his head while trying to fix the problem. Will technical support help here? I want to remind you that support specialists are usually low-skilled workers who answer users' questions and who can identify problems. Imagine that the technical support specialist is a configured Ikebana. In this case, it is not possible because your entire IT circuit is a monolith. And what is a monolith? A monolith can be any IT circuit, but the key property of a monolith is the fact that in any software complex, no matter whether it is a microservice or not, every extra feature will cost you more and take longer to deploy. And it is up to managers and engineers to make sure not to reach that point, after which any feature becomes unreasonable to deploy, time-wise and cost-wise. That's the point of no return, because features will keep on coming, but you won't have time to deploy them. Technical support can configure login without even knowing what is going on through the interfaces. It's important to understand abnormalities because that's what technical support always works with. For example, yesterday there was 20,000 entities going through the interface and today there are only 10,000. Is that a normal deviation? If it's more than half, then it's not normal. Okay, so 9,000 won't be normal anymore. Let's move on to message brokers. Why shouldn't you use a message broker? It should be encapsulated. It is the responsibility of the engineer because the supplier can tell you that he doesn't know how to compile diffs. He wants to send you all his goods and all his prices every 20 minutes. But in the case where we originally said that in our smart scheme there should be a message broker, it will be difficult for us to do that. The example is wrong. This is a real answer from a developer. A very cool developer, but who failed the certification. There it is. There are also logical errors, but that's fine. This is not the only case. I have dozens of such schemes. It will also require a refactoring of everything when something in the subject area will change. What does the domain-driven design tell us? Has anyone read Eric Evans? Make sure you read him because otherwise you just can't do deployments. Eric Evans says that if you have a subject area that differs from the technical solution, and if engineers don't think in the same terms as business, the architecture is bad. The ESB concept is the concept of service-oriented architecture. This is actually a business development concept where every department should be responsible for something. Even in very large organizations, I often hear things such as who's responsible for calculating year-end bonus. It's not clear. The rules are written in one system, then using POS systems, they're somehow transformed and sent to some CRM system. Then it is somehow calculated. Who does that? It's not clear. In that case, it's impossible to build understandable streams. It's going to be a mess, just like I showed you earlier. And this is a consequence of the fact that you can't make the right architecture without breaking relationships. The first brick for building normal integrations must be a service card. That is when you just say, this is a CRM system, it is responsible for this. So what should be the output of a CRM system? Customer relations, a customer database and how we communicate with them. An OMS with customer orders. What should be the output of an eShop? Orders, a PIM system and a master system with information about goods. Once you start breaking relationships, it becomes loosely coupled. This is the key principle of engineering, which is very often, too often, is violated. If you have breakable relationships between systems, between threads, it will be easy to support or replace any system. Look at the modern world. What does it consist of? It consists of a huge amount of products. If you have correctly constructed the IT circuit, you can add any cloud solution already today. So you're just burying innovations in the company because if you have such integrations, any new solution will become a year-long project for which, of course, there won't be a budget. To sum up with the myth, ESBs are not message brokers because we have a microservice architecture. If you still think so, you need to reread Thomas Earl. Microservice architecture is just an architecture of one context, bounded context, just like a single application. A CRM system can be a microservice, an eShop can be a microservice, but the exchange between them will never be a microservice. It's clear that integrations are usually microservices, but in terms of organizational structure, they're services, different services. Speaking about low-code and own solutions, I've heard in very large companies with thousands of engineers that ESBs are bad and that they prefer writing their own solutions. Well, that's great. So Talend has worked on its connectors for the past 20 years, analyzing for contradictions, and has been engaged in GUI for 20 years. But these guys here are super smart and will write their own solution. As one Pythonist once told me, I sneeze and I get 25 lines of code. Such typewriters always end up burning out. And then you get organizational problems and innovations are buried. IT directors take the whole company hostage. That's what happens when you start integrating an ESB and when you start using middleware. If you can't do that, it means that you have mixed contexts. And that means bad architecture, meaning that you're already on this curve, somewhere high up. Speaking about solutions, it could be anything. I'm simply pointing out that if your integration does not meet such a simple parameter that you can easily delegate responsibility for the connector to any system, you will have to hire someone who will be responsible for this integration. And this is bad. And in addition, in a normal business where managers do what they should be doing, like managing and creating standards, your accountant, for example, may want to integrate 1S with Google Forms. No-code tools will allow you to do this. There is no way that you will teach an accountant to use code first. You won't say, "Write me a quick connector, I'll publish it." That's not how it works. So the development of innovation points should be very important for managers and IT directors who want to accelerate the performance of their companies. And about no-code, it's your choice to use it or not to use it. But even if you have a code-first solution, it will be better than nothing. Of course, all modern ESBs tend there anyways. iPaaS is basically a no-code solution if you look at the development generation. As they said in Google in 2021, no-code is a new low-code. That's because Google faces exactly the same problems that any other organization. Any change should be implemented, as it will straighten you. You will become a little closer to the good culture of innovation. That's it. Thank you.